welcome to this second part of fluid mechanics. In the first part, we deal with the introduction to fluid mechanics, then we deal with the fluid properties. Now we are going to be dealing with viscosity, shear stresses, shear force, and the Newton's law of viscosity. So to start with, let us define some formulas that we are going to be using. Let's define some formulas that we're going to be using. Firstly, the first formula is V is equals to dynamic viscosity over density. This is kinematic viscosity, and this is dynamic viscosity. This is density. Dynamic viscosity is measured in Newton seconds per meter square. It's measured in Newton seconds per meter square. So, but at times you can have it in poise. So, what is poise? Poise is one poise is equals to 0.1 Newton seconds per meter square. You get. So that's just the secret. And you can also have stroke too. Stroke is one stroke is equals to 10 raised to power 4 Newton seconds per meter square. So that's just what we have for those ones. The next formula is shear stress. Shear stress is equals to dynamic viscosity multiplied by du dy. This u is the velocity, this y is the thickness or distance. So you can also have this as shear stress is equals to dynamic viscosity multiplied by v over dt, that is velocity and thickness, depending on how you are given. So now the last one is the force. What is force? We all know that shear stress is supposed to be force over area. So that's where we got this formula from. So if this is force over area, force will be what? Shear stress multiplied by area. So shear stress multiplied by area. So we can bring this formula here. We now have force is equals to dynamic viscosity multiplied by v over t, that is velocity over the thickness, then multiplied by the area. This is called the Newton's law of viscosity. So that's just it. I don't think we have any formula to know for now, but let me just give us this one. For angles, when your weight is sliding down and making an angle to the horizontal, your weight is said to be W sine theta. That is, if your weight is sliding down this parallel along this motion and is making an angle to the horizontal, we have this as the weight. So let's continue now. A liquid has a specific gravity of 1.9. We have been given specific gravity as 1.9. Let's see given. It's more advisable to write the given parameters out so that we don't have issues. What are we given again? And kinematic viscosity of 6 stroke. So we have kinematic viscosity, which is V, as what? 6 strokes. Now recall, we already said a stroke is times 10 raised to power 4. So this will be 6 times 10 raised to power 4. Raised to power minus 4 rather, in Newton seconds per meter square. So this one is set to. Now we are looking for the dynamic viscosity. That means we are using this formula, which is V is equals to dynamic viscosity over the density. But we don't have density. We still need to look for density. So to get density, let me add it here too. Density is specific gravity multiplied by 1000. Do you know how we got this formula? If you remember in our last class, we said specific gravity is density of that substance that we are dealing with over density of water, which is 1000, right? So when you have specific gravity, it is that density over 1000. So now if you bring this density, you see that this will multiply this, so you have density is equals to specific gravity times 1000. So that's how we came about that formula there. So what is our specific gravity? It is 1.9 times 1000. So that should give us 1900 kilogram per meter cube. So now bring it, let's be putting in our parameters now since we have everything. So now V is equals to what? Uh, okay, we have V, right? We have V. So let's put it down. We have 6 times 10 raised to power minus 4 is equals to our dynamic viscosity which we are looking for over the density 1900. So that will be this is equals to this times this, and our answer should be, let's calculate. We have 6 times 10 raised to power minus 4 multiplied by 1900 is giving us 1.14. Unit for um dynamic viscosity. Unit for dynamic viscosity is in let's continue. There should be an adjustment here. This is for kinematic viscosity here. So the unit for kinematic viscosity is meter square. Is not, this is for dynamic viscosity. So this should be here. So this is going to be meter square per seconds, yes, for viscosity. So now we are changing it to poise, and 1 poise is equals to 0.1 Newton in seconds per meter square. So what are we doing there? Since this one is here, it's going to divide. It's multiplying this and dividing this. This multiplied by this divided by this. If you don't get it clear, this is what I'm doing here. Since 1 poise is equals to 0.1 Newton seconds per meter square, and we are converting to poise, we have 1.14 here, x. So this times this divided by this. So you have 1.14 divided by 0.1. So let us check that. Divided by 0.1, we are getting 11.4. Yes, that's the correct answer. 11.4 poise. So that's just for the first question. Let's go to the second part. Okay, now the velocity distribution over a plate is given by this, and we have been told that this is the velocity. So remember that formula, we have du dy. That means we are differentiating this to know that. So let us bring that out first. U is equals to 3 over 2y minus 1 over 2y square. So du dy, as you can see, is with respect to y. So when you differentiate this, this will be rounded up to 1. We differentiate y to give you 1. Then 1 multiplied by this will be 3 over 2. Then for here, it will be 2y here. If we differentiate this, it will give us 2y. If we multiply 2y by this, 2 will cancel 2 and it will remain what? Y. So we have differentiated that one. That one has gone. So now the viscosity of the fluid is 8 poise. And when we are talking about poise, we should know that that is dynamic viscosity. So we have our dynamic viscosity to be what? 8 poise. And we already know that 1 poise from our formula here, 1 poise is 0.1. So we are multiplying by 0.1, which will be what? 0.8 Newton seconds per meter square. So that's just it. So we already have our dynamic viscosity. What else are we given? We are given y. 0.1 m. So we have to find the shear stress. We already know our formula in this place. So shear stress is equals to this multiplied by du dy. So it should be 0.8 multiplied by, but now let us read the question complete. We have to find the shear stress at the plate boundary, that is at the plate boundary is at 0, at y is equals to 0, and at y is equals to 0.5 meter. So we are doing this y, this one we are getting here. We are going to calculate it at y is equals to 0 here, and at y is equals to this for the second one. So let us start. For y is equals to 0, that is the plate boundary. The plate boundary we have du dy to be what? 3/2 minus 0, which is still 3/2. So just put 3/2 here divided by, what do we have there? 0.15. Let us do that. 0.8 multiplied by 3.3/2 should be 1.5. Yes, 1.5. Then over 0.15. 0.15. Yes. So let's see what we are getting. We are getting 8. We are getting 8 here. So our share this thing will be 8 Newton per meter cube. Yes. So for 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 this, since we already have du dy here, there was no need to bring this dy here, because normally if you differentiate this, it's going to give you 1. If you are differentiating a constant, is 1, so the y is not valid here. The y is supposed to be over 1 here. So we are using just this, and our answer will be 1.2 Newton per meter cube. That's an adjustment. So and now let's now do at y. For y equals 0.5 meter. The y was actually to insert your y when you get your du dy. So it's not for solving, it's not for inserting into the equation, it is for inserting into your y after you differentiate u with respect to y, so that you can do for plate boundary and you can do for the second y from the plates. So that's just what the y is for. So now du dy now will now be equals to 3 minus 2 minus 0.5, since y is here. Let us calculate du dy for the second one. So that should be 3/2 minus 0.15. So this is 1.35 here now. 1.35. So let us insert it. For y equals for y equals 0.5, we now pick that formula again. So this multiplied by du dy, and our du dy is this now, while our viscosity, the dynamic viscosity remains 0.8 times du dy is 1.35 now. So let us calculate 1.35 divided by 0.8 multiplied by, so that is 1.08 Newton per meter cube. So this one is for plate boundary. This answer is for plate boundary. Then this answer is for, this one is y is equals to 0, and this one is for y equals to 0.5. That's at the second place. So that's for that. So this is just how we go about it. So this is the final 2 answers there. Let's pause. In the next video we are going to be dealing with these questions now. In the next video we are going to be dealing with this.